Example 5 has a picture here and it says evaluate the definite integral. So the definite integral is just straightforward. What would the answer be if you do the antiderivative, plug in 3, plug in -2 and subtract? Next we're going to have to do some work extra here because it says if all the areas are positive, what would the total area of the shaded regions be? So that'll be a little bit different question, but we'll start with A and we'll just do the antiderivative. So this would be x cubed divided by 3 minus x squared divided by 2 minus 2x. And I'll plug in 3 first. So 3 cubed over 3 minus 3 squared over 2 minus 2 times 3 minus, and then I'm going to keep plugging in -2 in brackets so that I remember to distribute the negative to all terms. So I'll have -2 cubed over 3 minus -2 squared over 2 minus 2 times -2. And 3 cubed is 27. 27 divided by 3 is 9. Minus 9 halves minus 6. And then I'm going to distribute this and simplify at the same time. So here I end up with -8/3. With that negative distributed, it would be +8/3. Here I end up with 4 over 2, which is 2. It would be a negative. Distribute that, it would be a positive. And here we get a 4. Distribute the negative, it would be -4. So I'm going to combine all my integers first. 9 minus 6 is 3, plus 2 is 5, minus 4 is 1. And then I'll need a common denominator. I'm going to go for 6. So this will be 6 over 6 minus times 3 over 3. So it would be minus 27/6. And then times 2 over 2, so plus 16/6. So I end up with 6 minus 27 plus 16. So I end up with -5/6. All right. In order to check that answer, I can look graphically and see if that looks right. It's almost a -1. And so if I count my positives and my negatives and add them up, it should be about -1. Now, we haven't talked about negative area yet. When you have area above or shapes above the x-axis, those are going to be counted as positive area. Any area collected below the x-axis is negative area just because of the location. So location here, positive areas, here a negative area. So it looks like I've got about 1, 2, 3, 4, I would say about 4 in the negative side. Here I've got, maybe combine those, 1, 2, 3, 4 in the positives. So I thought maybe I'd get a little bit closer to 0. If I count here again, I have 1 full 1, 2 full 1s. Maybe if I combine those, it'd be 3. 4. I bet I have closer to 4 or 5, 4.5 or 5. So I do think that answer is reasonable. One other way to check is your calculator will do definite integrals for you, and I'll show you how to do that. If you go to math and go down until you find FN int for integral, my calculator might be older than yours, so you might have a different way to plug it in. But here, if you have this version, I'm going to plug in 4 things. First, I'm going to plug in the function x squared minus x minus 2, and then comma, and then an x that says that we're in terms of x, comma, and then the bottom number, which is -2, comma, and then the top number, which is 3. And we did get -5/6. We are right. So next we'll do part B. And part B says, if all areas were positive, what would the total area of the regions be? So because when I did the whole thing from start to finish, it counted positive, negative, positive, and it gave me a total. If I'm going to need all the areas to be positive, I'm going to have to do them all separate. So I'm going to have to make my own integral here from -2 to -1. The top is that quadratic function that made a parabola. So it's going to be A1. Next for A2, I'll have to do that. And A2 will be from -1 to 2. The top, or now because we're below the x-axis, the bottom is that same quadratic. And then plus A3 is going to be from 2 to 3. So 2 to 3, same top. So we will have the same antiderivative every time, but we'll have to plug in the values each time to see what each area would be and then add them up. So antiderivative we already have. It is x cubed over 3 minus x squared over 2 minus 2x. -2 to -1. So first I'll plug in -1, then I'll plug in -2, and I'll subtract. So here it looks like we'll get -1 cubed over 3 minus -1 squared over 2 minus 2 times -1 minus, keep the second number in brackets, so -2 cubed. I'm going to try to do a little bit more work in my head. So -2 cubed would be -8 thirds. -2 squared would be 4, so minus 4 divided by 2, so -2, and then plus 4. So we end up with here -1/3. Here we'll do -1/2, and then here we'll have +2. Distribute the minus, so we'd have plus 8/3 plus 2 minus 4. So A1 looks like it's going to be 2 plus 2 minus 4. That'll all cancel. Let's see. 8/3 minus 1/3, that would be 7/3 minus half. I'll let my calculator do it. So 7/3 minus half, it's going to be 11/6. So that's A1. Now I got to do A2, and kind of looks like I'm going to run out of room here. So here's my antiderivative. I'm going to plug in 2. So 2 cubed is 8/3. 2 squared is 4. 4 divided by 2 is 2, so -2, and then -4. Then I'll plug in -1, and I've already plugged in -1. I did it here, so I'm going to steal those answers. So -1/3, -1/2, plus 2. So I end up with 8/3 minus 6, distribute, plus 1/3, plus 1/2, minus 2. So it looks like I'll end up with -8 and plus 9/3, which is plus 3, and plus half. So I end up with -8 plus 3 plus half. So I end up with -4.5. Now, because I wanted everything to be positive, I will have to take and put absolute value signs around this whole answer and get 4.5 that way. Since I'm out of room, when you do A3, which I've already done, when you plug in 3 and plug in 2 and subtract, these are congruent shapes, and so you do get the same answer for A3 as you did for A1, so it's 11/6. So just a little time saver, I'll tell you that. So A1 plus A2 plus A3, so we have 11/6 and 11/6, so 11/6 times 2 plus 4.5. So 11/6 times 2 plus 4.5, we end up with 49/6 as our total area with all pieces positive.